Suppose Hernandez Limited randomly varies its price over a period of time as well as across cities in order to collect information on its demand curve. An ordinary least squares regression of weekly quantity on price, population, per capita income, and annual advertising expenditures generates the output shown in the table. All variables were entered in linear form, which just means that our regression has estimated a demand curve which is a straight line. In a market with population, per capita income, and advertising expenditures all in thousands of 100, 25, and 20 respectively, an approximate 95% confidence interval for the quantity demanded at a price of $5 is blank. So we're going to be solving for a 95% confidence interval for the quantity demanded, but first we need to find our estimated quantity. Estimated quantity is estimated by first starting with our constant and then adding all of our coefficients times our variables. And in this case, we find 2,000 units as our estimated quantity sold. So to find a 95% confidence interval, we're going to take that estimated quantity and we're going to add and subtract 2 times the root mean squared error, which in this case, the root mean squared error is 200. So we're going to have 2,000 plus and minus 400, giving us a 95% confidence interval of 1,600 to 2,400. The next question asked, an approximate 95% confidence interval for the slope of the demand curve is blank. Well, we know that the slope is equal to the price coefficient. In this case, the price coefficient is negative 400. The 95% confidence interval is going to be equal to that slope plus and minus 2 times that variable's standard error. Since we're not doing a 95% confidence interval on the quantity demanded, we're not going to use the root mean squared error. When we're doing our confidence interval on one of the variables, we're going to use that variable's standard error. So in this case, the slope was negative 400. The standard error was 150, so we're going to do negative 400 plus and minus 2 times 150, or 300. And that gives us an approximate 95% confidence interval for the slope of the demand curve equal to negative 700 to negative 100.